Dear students, in this lecture video, we studied about the voltage control by using transformers. How to control the voltage with the help of transformers. Here, I am using tap changing transformer for controlling voltage. The voltage control using tap changing transformer is the basic method and then the basic way and then easiest way also for controlling the voltages in transmission side, sub-transmission side and then distribution system also. Because the power system is nothing but what? Generation, transmission, sub-transmission and distribution. The transmission level, that means what? From generating station to, that means then substations and all, then again sub transmission, okay, then again from substation to consumer and all distribution. So therefore we are using the tap changing transformer and then which is used to control the voltage in the transmission system, sub transmission system and distribution system. In high voltage, that is HV, and the extra high voltage, which is abbreviated EHV, lines on load tap changing, which is abbreviated by OLTC. OLTC means on line tap changing transformer, which are used, and then while the ordinary off-load tap changer, that means prevail in the distribution circuit only, we are using the off-load, that means tap changer transformer. But for high voltage and then extra high voltage, this is the transmission and sub-transmission side, we can use the on-load tap changing only. What is the meaning of on-load tap changing? Mean the transformer is on service, we can change the tap changing switches, that is called as the on load tap changing. Off load tap changing means you can switch off the power supply and then the transformer is, that means is in offline only, that is not in service. That time we can change the tap changing switch, that is called as the off load tap changing. Already on load tap changer transformer and then off load tap changing transformers you are studied in the third semester in transformer and generator subjects. Okay, so now here the tap changing transformers do not generate reactive power. This is very important. Okay, I already told you, that means what? The transformers always, that means what? Absorb the reactive power only. Okay, because the generator only generate the power. The transformer either stepped up or stepped down, but only then it transmit only. So it do not generate reactive power. The transformer always absorb the reactive power only. We already studied, comes under the topic production and absorption of reactive power in the lecture video 2 in the same module 4. Okay, so now we can consider the operation of the transmission line with the tap changing transformer at both end, means receiving end as well as the sending end. Now you see the circuit diagram. This is the transmission line with the tap setting transformer, that is the tap changing. Okay, you see this is the indication of the tap setting center into both end. This is the sending end, this is the receiving end. Okay, so the V1 is the sending end voltage, V2 is the receiving end voltage, but the actual voltage is nothing but TS into V1 and TR into V2, where TS and TR is nothing but the off nominal tap setting of the transformers at the sending end and the receiving end respectively. See, after the tap setting, what is the actual voltage here? That means that is the after, that means that is the tap setting before, that means what is the receiving end voltage. So now I explained with one example. The one transformer is there, the transformer ratio is 6 kV to 33 kV, but the tapping is 6.6 kV to 36 kV. Okay, now we can set the off nominal tap setting. Okay, off nominal tap setting, that means TR at TS, that is 36 divided by 33, that is equal to 1.09. That means the transformer is equivalent to the transformer with the nominal ratio 6.6 kV to 33 kV in series with the auto transformer. That auto transformer ratio only 33 is to 36. So therefore 1 is to 1.09 only. Now see, this is the V1, okay, sending end voltage. After tap setting, that is the ratio 1 is to TS, and then the actual voltage is TSV1. This is the impedance R plus JX. Then again TR, this is the actual voltage of the receiving end. Then now you can tap changing. This is the TR is to 1 ratio. Then we are getting the receiving end voltage T2. You see, in the following discussion, the magnitude of the voltages V1 and V2. Okay. So the V1 and V2 is nothing but what? Nominal voltages of, that means receiving end as well as the sending end. Okay. So the transmission line voltage normally 33 kV, 66 kV, 132 kV, 400 kV. Okay. At the end of the transmission line, the actual voltage is nothing but TS into V1 and TR into V2. This is the actual voltage of sending end is TX into V1, receiving end TR into V2. We already that means seen in the figure. Okay, so it is required to determine the tap changing ratio required to completely the compensate of the voltage drop in the transmission line. Which one is determined? The tap changing ratio. The tap changing ratio, previously we studied, no, 36 divided by 33, that is equal to 1.09. So therefore the ratio 1 is to 1.09. This is the tap changing ratio. So therefore the tap changing ratio only is used to determine to complete compensation for the voltage drop in the transmission line. Okay, this is the concept. Now you see, that is the product of, that means TS into TR. This is made unity. That means TS multiplied by TR, that is equal to 1. The TS and TR is nothing but what? Once again I repeated, this is nothing but the half nominal. That means voltage at sending end and receiving end respectively. Okay. So the overall voltage level remains in the same order and the minimum range of the tap on both sides, that is receiving end side as well as sending end side also is used. Okay, what is the total impedance of the transmission line and transformers is referred to high voltage side is nothing but R plus JXX. Students, I already told high voltage side and then HV voltage side we are using the on load tap changer only. Okay, so then other thing only we have to use the off load tap changer. Okay, so therefore the total impedance of the line and the transformers referred to high voltage side only, that is R plus JX, which is represented in the diagram. Dear student, under this topic, how the question will come in VTU University exam, explain the voltage control using transformers. Otherwise, how to control the voltage using a transformer or tap changing transformer? You draw the diagram and then you can explain. Then when I told one example for your understanding purpose, how to understand the concept. With the example only you can easily understand. If simply I am saying what is the ratio here, is there no, that is the ratio, tap changing the ratio, you didn't understand. No? So therefore we have to, I tell one example from this length I explain. So you draw the diagram, you can give one example and then you can explain this only. This is the minimum 6 mark, that is the 6 mark questions only. Okay, students, thank you students for listening this video.